Hello. Yeah. Very good afternoon, ladies and gentlemen, dear guests. Welcome to this session on training session 3 is local initiatives driving better railway asset management and maintenance. My name is Mohammad Nazrul Islam. I am the Senior Transport Specialist from Transport Sector Office, Asian Development Bank. As you all know, railway asset management and maintenance are very critical because railways are long life, capital intensive, safety critical systems. That is the top priority for our railway undertakings. The session will focus on planning stage initiatives jointly supported by Asian Development Bank and Bangladesh Railway to improve railway operational performance through maintenance modernization and capacity building of Bangladesh Railway Academy. And this session will try to highlight how strategic planning, institutional readiness, and targeted use of high-level technologies, that is called HLT, are laying the foundation for future operational efficiency improvements through railway systems. Key objectives of this session is to present Bangladesh Railway's current status and its planning priorities for railway maintenance improvement, and also to highlight the role of Railway Training Academy in supporting system-wide capacity development. And also, we'll discuss how planning stage interventions can prepare railways in future digitalization and high-level technology adoption. And the session also try to share early lessons relevant to the other railway administrations across the regions. So with this, I would like to invite 4 of our speakers and 1 discussant. So I would like to invite, first of all, Satomi Sakaguchi, Senior Transport Specialist, who will introduce ADB Railway portfolio, Central Asia, South Asia, and Southeast Asia. And then, Satomi-chan, you can come over the stage. And then I would like to invite on stage Al-Fattah Muhammad Masudur Rahman. He is the Additional Director General Infrastructure of Bangladesh Railway, who will present here today the key learning of his GRACE workshop. He participated in 2025 on railway asset management, how to use those knowledge and support an active maintenance strategy for Bangladesh Railway. Our next speaker would be Mr. Muhammad Salimullah Bahar. Mr. Bahar is the rector for Bangladesh Railway Training Academy, and he will also present today capacity development program for Railway Training Academy and its current status and planned reforms in future. And one important speaker who has kindly joined online, Professor Peter Witt. He is the professor of Technical University Grace, and Professor Peter Witt will present online and also will be given his valuable speech on the railway asset management and maintenance system and how we can relate with the Bangladesh systems and for in its future modernization initiatives. And the last but not the least, I would like to invite Mr. Oleg Samokhin, Senior Transport Specialist, Asian Development Bank, who has extensive knowledge on the regional railway. He will be the discussant for Q&A sessions. So thank you very much, speakers and discussant, for your kind joining in the sessions. And Professor Witt, thank you very much for your online joining. Thank you.
Good afternoon, everyone. Thank you, Nazrul, for introduction. And my name is Satomi Sakaguchi, transport specialist from Railway Logistics team. And today I'd like to provide a very brief overview of our work in the railway and logistics sector at ADB. So some of you who have joined the session yesterday may have seen the similar slides, but to start the presentation, I'd like to highlight how much our sector, subsector, railway subsector share has increased in past 10 years in terms of commitments. So its increase is as much as 33%. Before, road subsector was overwhelmingly the number one share sector. However, now rail subsector share has increased to nearly half of our entire commitments. So what this is how we have been doing recently. And we are currently looking at more new and expanding opportunities in our transport sector overall. Many of which really touch upon the importance of railway as transport mode. For example, we are continuously faced with the need of increasing mass transit network, and then connectivity with new transport modes, and the contribution to urban traffic management and air quality improvement, and regional and urban development, and connectivity with maritime and inland waterways, and new fuels, introduction of new fuels. And importantly, we have been pressed with expected to work more on improving efficiency of the existing or legacy railway systems. System operation efficiency, system electrification, digitalization, and another area where big contribution is expected from our subsector is regional cooperation and integration, which I will touch upon a bit more in next few slides. And of course, we need to continue to work with private sector participation, as has been very much highlighted by the panelists at yesterday's sessions. So let us look at some of the key opportunities and priority areas for the railway sector of ADB. So first is the RCI, or Regional Cooperation Integration. The ADB has committed targets for achieving impact in terms of regional cooperation and integration across all sectors. And we have targeted increasing committed operation for next 3 years. And then we also have the target in terms of different sectors in terms of contribution of these targets. As you can see on the chart on the right, the transport sector is supposed to provide biggest contribution. And so therefore, we are in the need to incorporate the elements for contributing to this very important goal of connecting our member countries across countries and regions in our railway projects. We have already existing framework through which to promote regional cooperation integration. And of these frameworks, railway development is integrated as sort of a backbone of promoting regional cooperation integration. So we have the one framework is Greater Mekong Sub-region, and this is the cooperation, the framework across this region in Mekong, such as Vietnam, Cambodia, and next one, SASEC, South Asia Sub-Regional Economic Cooperation, and CAREC, Central and West Asia region, and lastly, BIMPEN-IAGA framework. So most of these four key frameworks for promoting regional cooperation integration, as you can see, promoting cross-border, promoting cross-border railway network, supporting logistic development. And these are considered as backbone of this framework. And another key priority areas where rail subsector is expected to make a big contribution is regional and urban integration. So as we have looked at yesterday, we have two flagship projects, particularly promoting this priority. First, here in the Philippines, we have two very large railway projects, Malolos-Clark Railway Project and South Commuter Railway Project. So I think this project probably some of you are already very familiar with. So idea is to disperse the heavy concentration of the population, the economy, education, and health, all other opportunities within Metro Manila to other regions surrounding this capital area, and therefore promote sustainable urban and spatial development. And another project which is very important for promoting this priority is the Delhi-Meerut Regional Rapid Transit System Investment Project in Delhi, India. So this Delhi is also similarly very much over the concentrated city, and in terms of economy, education, and other business opportunity. So idea is to disperse all such concentration to surrounding 3 states by providing seamless, semi-high speed, very efficient integrated railway connectivity. So this is the list of all the ongoing projects and the targeted at achieving these priorities. In South Asia, we have a large number of projects in countries like Bangladesh and India. We have a project in Central and West Asia and also Southeast Asia. Now, for next few slides, I'd like to look at some of the more recent projects which address particular areas of priority, such as efficiency improvement, digitalization, electrification. So first one is Azerbaijan Railway Transformation Project. As you know, many of the Central and Western countries have legacy railway systems, and these are the very much used by passengers in those countries, but they are in grave need for improvement and the modernization. So this is one of those projects. You may see the amount of the loan as relatively small. However, this project has very important components such as digitalization of key processes in Azerbaijan railways, including cargo operation and management, asset management, investment planning, and construction management, and the cargo commercial system and corporate functions. This was approved in September 2024. Next one is Nagpur Metro Railway Project in the state of Maharashtra, India. So this the project, metro project, and this provides a very comprehensive approach to addressing urban congestion. And it has the integrate very much well planned out TOD project at all stations, and entire process of project development from conceptualization up to operation and management has been done on the platform on building information modeling. And for the first time, at least for ADB project, this project has adopted 6-dimension BIM system. And then the project also has its components, skills training for the disadvantaged women living across the alignment. So, well, it might seem obvious that this kind of urban railways bring a lot of benefits to local people, but to expand the reach to those people, even very disadvantaged people, we included very forward-looking initiative as part of this project. So this was approved in June 2024. And then another one, this is new, exciting, the restart of our engagement with the Pakistan Railways, preparing the railway improvement project. This is what we call project readiness financing loan to support project preparation, such as feasibility study, detailed design, and early procurement activities. This particular one will support detailed design for the ensuing project, including the very important main line one, of which this red line, 480 kilometers between, sorry, the name is missing, but the city in the bottom is Karachi to Rowley. This is very priority line to be studied under this project readiness financing loan. And it plans to have connectivity at Karachi to the port. So it's going to provide a very integrated solution overall. And lastly, and of course not least, we've been very comprehensive long-term engagement with the Bangladesh Railways, which we are very much proud of. And we have provided so far 8 loans, totaling 3.7 billion. So the focus of our engagements are very wide-ranging. So we combine institutional strengthening with physical investments and modernization, standardization, and capacity enhancement. And we have particularly focused on the priority corridor between Dhaka, Chattogram, and Cox's Bazar. And over many years, we have implemented sort of master plan approach across this network. So looking further into the future, we are seeing these priorities coming up. First, even more integrated transport systems, connecting critical missing links, more multimodal solutions, and one-stop integrated solution from policy to investment to operation. And improved access, as we talked about, as we discussed yesterday, and also I just mentioned in relation to Nagpur Metro project, we need to plan accessibility from the day one of preparing a project. And of course, sustainability, reducing negative externality. As you know, ADB has made effective our new safeguard framework starting from this year. So we will continue to focus on sustainability, climate and disaster resilience, and other safeguard aspects. So considering all these priorities, we are preparing this project in the coming 3 years, which indeed we are very proud of, very exciting list. So as you could see, in the past, for ongoing project, we had a lot of projects in South Asia, but now we are increasing our presence more into Central and West Asia, and also Southeast Asia as well. In South Asia, we will continue to engage with key countries like Bangladesh, India, and Sri Lanka. Many metro project and the railway project. And the Central and West Asia, we have a flagship project like INDER project in Turkey, but also a number of modernization and capacity enhancement projects. And also here in Southeast Asia, we are working on fast MRT project in Indonesia, and many more projects in the Philippines to come. So overall, this is the snapshot of our subsector operations, and thank you very much for listening.
Thank you so much, Satomi-san. Now we would like to invite Additional Director General, Bangladesh Railway, to kindly give his presentation.
Good afternoon, everybody. Actually, my presentation topics is data-driven and sustainable asset management for Bangladesh Railway. Actually, ADB is supporting from the very long time. ADB has taken initiatives to make the maintenance system to digital. So we have attended different workshop in Graz, Austria, and according to their idea, we are trying to have some data-driven railway infrastructure management. So my topics is divided into some key items, that is key learning from Graz workshop, situation analysis, current asset management systems and institutional gaps, digital transformation, planning for data-driven asset management practices, and strategic partnership with ADB. So sustainable railway asset management actually need to preserve service life, not only assets. The workshop framed railway infrastructure around reliability, availability, and maintenance. Investment creates initial quality. Maintenance is what converts the quality into long service life. Decision should account for full life cycle cost, including inspection, maintenance, and operational disruption. And maintenance is basically two types: reactive maintenance and predictive asset management. So reactive maintenance pushed the network into emergency repairs, fragmented records, and short-term budgeting. And predictive asset management uses a centralized registry, condition trends, and planned interventions. The practical benefit is lower life cycle cost, higher asset availability, and better train operation reliability. Life cycle cost must include operational hindrance. A technically cheaper option can become costly when delays, capacity loss, and speed restrictions are counted. The Graz findings is a system warning. Partial optimum is not the same system optimum. Asset decisions should combine engineering analysis, economic evaluation, and operational simulation and forecasting. So data-driven railway sustainability, actually digital intelligence is operating layer of sustainability. Sustainability depends on track quality, behavior analysis, deterioration modeling, and long-term maintenance planning. A good track deteriorates slowly, a poor track deteriorates faster and demands more frequent intervention. Actually, we have planned Bangladesh Railway asset management system that should connect data, GIS visibility, analytics, and predictive maintenance planning. So finally, our existing maintenance system, actually it is a reactive maintenance system in Bangladesh Railway. Unexpected asset failures lead to emergency repair, operational disruptions, higher maintenance cost, reduced asset lifespan, and insufficient resource utilization due to absence of predictive and preventive maintenance system. And it is paper-based and fragmented record-based, identification, and delay report, inconsistent data, delay reporting, weak coordination, and slow decision making. And visibility is also poor visibility. And the track deterioration, actually, if we can do the according to the reactive maintenance, actually we attend after deterioration. So if one, component is deteriorated and it is attended from very beginning, in that case the other component cannot be failed. So the reactive model and predictive model, the difference of reactive model and predictive models are actually reactive model is paper based and predictive model is real time digital asset register. Structure is fragmented in Bangladesh Railway, that is east-west, east zone and west zone. Our data and maintenance structure is fragmented, but we need to have unified integrated platform that provides the DG and ministry with a single source of truth across all zones. Maintenance strategy is reactive, and our target is to predictive and preventive maintenance. Procurement is actually historical estimate preparation and manual procurement, but target is the data-driven planning and doing the contract. So actually we have done some pilot pilot work, asset visualization on map. What we have done, that is web GIS based railway track bridge MIS platform. In that pilot project, we have identified the railway assets on a digital map interface. Different asset categories such as track, bridges, stations, junctions, level crossings. Key benefits we got: improved visibility of railway infrastructure assets, faster identification of asset locations and conditions, better support for maintenance planning and decision making, user-friendly interface for operational management teams, enhanced coordination through centralized asset information. RTBMIS web-based GIS platform enabled digital visualization of track and bridge inspection conditions. Actually, according to the present maintenance system, we have some register. We put the information in the register, but web-based presentation, we do the inspection and record it in the software. And in that case, we get real-time visualization of inspection and condition data, color-coded condition indicators for easy status identification, integrated monitoring of track fittings and sleepers and bridges, improved identification of critical and vulnerable asset locations, faster reporting and maintenance decision support. Another thing is that we get year-wise comparison of railway track in this analysis. According to the manual inspection, we input that data in the web-based GIS platform system, and we get year-wise condition of the track. We use the track tamping machine for maintaining the track. So at present, this system is that it works locally, but in this system we can we can see the working status of the machine. The RTBMIS platform successfully demonstrated real-time tracking and visualization of the tamping type machine work, so that centralized monitoring could be possible. And we have the present maintenance system. There are some railway track maintenance gang. So gangs work controlled locally, but in that in our pilot project we we prepared some mobile app so that they input data from their gang, and centrally we can observe their working position, and their data is installed in our system. So digital attendance recording of maintenance gang is possible. Mobile-based task assignment and monitoring can be done. Real-time tracking of work progress and task completion can be done. Centralized management of dashboard for the supervisors we can do. Besides that, RTB MIS platform demonstrated centralized reporting and dashboard capabilities of railway track and bridge assets, enabling data-driven monitoring, analysis, and decision-making. And by doing this, faster access to operational and inspection information, improved management oversight through summarized analytics can be done. So, Unified Asset Registry, actually, we want to do some unified geospatial platform that will in that platform, all data, track data, land parcel data, bridge data, inventory, and schedule of rates will be included. Finally, we can do the land management through this system. So all the land data will be included in this system, and digital cadastral integration can be done, and we can identify our land through this platform. And POA diagram, we maintain manual POA diagram that would be included in this system. And smart inventory control also possible through this system. And in the field, if in some place there is some emergency, they can put the emergency alert so that everybody of this system can identify where the situation comes. And it will actually bridge the gap real-time synchronization. Actually, by mobile app, they will put the data, and in the office, the supervisors can plan with using this data. Actually, standard, the predictive and web-based dashboard, it is just sample of this dashboard. We can make it, and you know, our life cycle value cost curve, along the time, the asset condition become deteriorating. So if we can do the smart maintenance, in that case, the asset condition will be better. So the current reality of that the government of Bangladesh making unprecedented financial commitments to clear decades of deferred maintenance. But through this data, we can apply to the government that what is the present requirement. At this moment, actually, we can manually do, but government cannot afford that budget. But how, according to this, digitalization, we can make the government understand that what is the requirement. Actually, the strategic architect of ADB, ADB is our 60 years partners for complex problem solving. The scale of commitment, 36 billion invested in Bangladesh, representing to 35% of total lending across the region. The Finance Plus model is done by ADB, and after having this pilot project, ADB will come forward to support at planning stages, and for funding, value addition, scale up, and enabling environment, they will do our fulfill our requirement. Finally, it can be told that Railway Land Value Capture Transit-Oriented Development Program in Railway Safety and Critical Infrastructure Sustainability Program, in Railway Maintenance, Financing and Life Cycle Investment Program, and Bangladesh Railway Integrated Asset Management Modernization Program, ADB will have the partnership with Bangladesh Railway. So thank you, everybody. Thank you all.
Thank you so much. Thank you so much, ADGI, for your excellent presentations. And then we are also really happy from Asian Development Bank that we could, a good partner of you, and then we'll continue our working together. So at this stage, I would like to invite Rector, Bangladesh Training Academy, to give his kind presentations. He will cover the capacity development of Bangladesh Railway Academy and the current status and future planned programs on reforms. Please, Mr. Bahar.
Thank you, everybody. Thanks to ADB for giving the opportunity to attend Asia and the Pacific Transportation Forum 2026. We will proceed. This is SM Salimullah Bahar, Rector, Railway Training Academy, Bangladesh. I present upgrading the Railway Training Academy to enhance the capacity of Bangladesh Railway. I'd like to highlight the topics to present. The role of Railway Training Academy, modernization of training facilities, reimagining the growth of Bangladesh Railway by a freight-driven commercial approach, linking maintenance reform and workforce capability development. Finally, the expectation of ADB. The RTA has some history, and it was established after independence of Bangladesh, 1983. RTA at a glance, it has 6,116 square meter land area, 2,76,765 square meter. The objective of RTA, it imparts training in various engineering and operating matter, including safety rule to the officers and staff of different disciplines of the railway. It makes them not only conscious of the responsibilities vested in them, but also prepare them to discharge their duties efficiently. The function of RTA to conduct foundation course, final course, promotion course, and refresher course to its officers and staff, including supervisors, skilled staff for engineering, mechanical, signal, telecommunication, transportation, commercial, stores, medical accounts, Nirapatta Bahini, and personnel department. The RTA's vision to be a pioneer in training and an institute of excellence to develop organizationally effective personnel with pride in their work and faith in the management. Its mission is to train fresh recruits to acquire competency with adequate knowledge, adequate skill, and apt attitude to excellence, excel in their profession to achieve the goal of safe, punctual, and cost-effective transportation. To make training as a tool to inculcate a sense of responsibility and ownership among all railway staff to achieve the objectives of Bangladesh Railway. There are some core values to ensure that employees are equipped with the right kind of skill, knowledge, and abilities to perform their assigned task. Training and development play a crucial role toward the growth and success of any organization. It provides different courses and conducted by RTA. This is an environmental feature. The present total land area of RTA 276,765 square meter. The academy is surrounded by about 2,200 species of fruit, forest, and medicinal plant, including many other trees. There are organogram, some infrastructure and other facilities of academy. There is limitations of RTA. Training Academy has no collaboration with state-of-the-art technology and training methodology of other railway institutes. No updated training manual and modules, except some handwritten notes made by the trainer and senior instructor in RTA. No provision of research work for advising modern railway system, including passenger services, infrastructure, maintenance, latest tools and technologies. project management and driven training. No safety commission or unit for inquiring into railway accidents and obliging findings management. The anticipation of future development to promote an international standards. Future anticipation for developing general facilities may include academic building, dormitory, guest house, auditorium for international seminar, workshop, conference, library facilities, library and training aid, book and journal, etc. Sports facilities, swimming pool, gymnasium, indoor games and outdoor game facilities, cafeteria, dining room, etc. The technical anticipation, future anticipation for developing technical facilities, including but not limited on digital laboratory for geotechnical engineering, ballast and aggregate, cement and concrete, ultrasonic testing of rails, and welding and other non-destructive tests. Digital model room and digital library, track and bridge components maintenance and operation procedure, rolling stock maintenance and operation procedure, signaling and interlocking system maintenance and operation procedure, control cabin operation, procurement procedure, key troubleshooting of all departments, BG and MG locomotive simulator for speedy training of locomaster. In order to meet up the anticipation, a feasibility study with detailed design for expansion and modernization of Railway Training Academy proposal is approved and hopefully to be completed within 1 year. This research and innovation are for RTA. The goal of rail research and innovation of RTA is to improve capacity, efficiency, and sustainability throughout automation, digital technology, and infrastructural improvement. Application of AI and robotic in rail research by enhancing predictive maintenance, optimizing operations, and infrastructure autonomous train operations, robotic inspection of track and rolling stock, and optimizing complex timetabling. Explore electrification of entire rail operations and alternate fuels for rail engines such as hydrogen, LNG, and biofuels. All seaport should be intermodal interfaces and contemporary dry ports should be developed nationwide for modal shifts from road to rail. Special features on rail freight. Rail intermodal connectivity is required in new port. Projects such as Bay Terminal, Madarbari Deep Seaport, and other to reach the hinterland directly. Modal shift from road to rail, irrespective to container or other cargo, is inland freight transport. To emphasize freight movement for domestic and international trade, especially training is required and need to set separate division in producing skilled human resource under RTA. Need to work on urban rail freights to reduce congestion in the major cities where rail is alternative of road mode. Priority maintenance reform. Priority maintenance reform and workforce capability development are anticipated to improve the reliability and efficiency of Bangladesh Railway with the help of RTA. The development of a SOP, Standard Operating Procedure manual for mechanical and other staff about maintenance practices in Bangladesh Railway. Establish a model lab to help trainees understand the design and operation of locomotive, bogies, carriages, and wagons conceptually. Also, a skill development lab for trade-specific maintenance need, such as assembly, disassembly, welding, and machining. Determine the standards of skill level using 50% theoretical and 50% practical knowledge. Develop module-based material for every level of mechanical staff, such as a fitter. Prepare a trainer's manual that include detailed information about classroom training hours, compensation, the range of modules that can be taught, the breadth of lateral entry from field level position. Finally, expectation from ADB. Technical assistant to develop RTA as a center of excellence for Bangladesh by providing the latest curriculum to train and procedure skilled human resource, a standard modern state-of-the-art academy, and its accreditation of all courses from the designated authority, university, and others. Financial assistance to develop infrastructure, modern rail simulator or model room for providing effective training to rail recruited employees as well as other university students inside Bangladesh. Introduce academic courses, honors or master's degree in rail engineering or management with the help of local and global universities. Special collaboration with the Asian Development Bank. Technical collaboration to develop rail freight and approach modal shift to rail and serve seafood to cover its hinterland by rail mode. Finally, the conclusion, due to its location is a noise-free and pleasant environment, and the amount of land under it, it is possible to build this academy as an international standard training institute, combining proper planning, prioritization, human resource development, and professional research with modern technology and facilities. This institute can be built as one of the best railway training center in South and Southeast Asia. Overall, RTA is seeking a strong collaboration with ADB to develop the academy and the Bangladesh Railway. Thank you all.
Thank you so much for your detailed and good presentation. At this stage, actually, we'd like to request Professor Peter Witt, who has kindly joined online. Professor, over to you.
Thank you. First of all, do you see my presentation?
Not yet.
Should come.
So while we are waiting for Professor,
So
yeah, it is here. Okay, over to you, Professor.
you see it.
Now
That's fine.
Yeah.
That's fine. First of all, thank you for inviting me to present my ideas of asset management. And special thanks, Mr. Rahman, to show how Bangladesh Railways implemented the key findings from the Graz seminar into their organization. I want now to describe the basics of asset management and maintenance as it is discussed in the lifecycle maintenance seminar. My name is Peter Veit. I'm coming from Graz University of Technology in Austria, where we more or less developed these ideas together with the Austrian Railways. So what are the tasks of asset management? We want to identify the best, most efficient, most sustainable, and thus most economic specific track, specific for the basic boundary conditions. For the specific boundary conditions, we call these boundary conditions parameters. Therefore, so there is not one track, the best track for all. We need to find the best track for a certain set of parameters. These, first of all, we need to identify these parameters. Of course, that's transport volume, rail in profile and steel grade, sleeper ready, but subsoil condition, and so on. We have different parameters identified for different countries. However, a track always faces a set of parameters, some special transport volume, some rail types, is it continuous or not, and what's with the subsoil. Out of data, we created standard elements So for each set of parameters, which is frequent in the network or relevant in the network, we put up a table showing what is the service life, what is the maintenance to be done when the planned maintenance. With these basics, which are data-based, so we require data from recording cars and so on, we can answer the questions: which component should be installed, which maintenance is required, and what is the intended service life, so the useful service life, the economic service life. These three questions must be answered simultaneously and require technical as well as economical evaluations. Why simultaneously? We cannot define which component we shall use if we don't know what are the maintenance requirements afterwards. What to consider? We need to have a systems view. That means when we are speaking about track maintenance and asset management of track, it is not enough to look on rail, sleeper, and ballast. We also have to look on sublayer, subgrade, and the dewatering system, which is very important as well. But even this is not enough, because the alignment is relevant, and we do all these things for transport. So we need the transport volume and perhaps the rolling stock. With this approach, we can avoid that we better the situation in one place and worsen it in another. It is always a system view to bring up the system as the entire system. When we go for economic evaluation, we have one basic, which is very simple. An economic evaluation needs to consider all costs influenced. However, when you decide on a component for a track, we have to think, how long does this component lead to costs? And of course, it leads to costs as long as it is installed, inspection, maintenance. Thus, economic evaluations need to be based on entire life cycle cost. And this requires predictions. Asset management is life cycle management. Asset management must be life cycle management. And as already mentioned by Mr. Rahman as well, we have operational disruption when we do maintenance. And these disruptions cost money. And these disruptions are therefore a consequence of maintenance and must be taken into account in the technical, in the economic evaluation. And we compare different options: heavier rail, lighter rail, concrete sleeper, wooden sleeper, and so on. These different options lead to different service lives. So we cannot compare the net present value only, because it is different service lives, and therefore we need to calculate the average dynamic annual costs, which is called annuity. This is the only cost figure which allows proper comparing of different options, having different investment and different service lives. And then we come to data. Data are essential, but data should be used and not just stored. And therefore, we need to go away from data to knowledge. We need to use our data to understand track behavior. I mentioned before, asset management is life cycle management, and therefore we need predictions. If we go for a prediction, we have to know how track behaves. Unfortunately, the direct way from data to knowledge does not exist. It is a cascade of steps we have to go. First of all, we get data, we have to verify them. If they are once stored, it's very hard to verify them. Then we have to position them. When we want to do time sequences, we need to know the exact point of the data of different recording car runs. This allows to go for time sequences, and time sequences show how is the trend, how does track behave, how does it deteriorate, and these trends are the basic for any forecasting. And as soon as we can predict how it will be, we have understood the system and we have the knowledge which we can use for steering the maintenance, for steering our decisions, and that's predictive maintenance. This is a picture of the lines. The colorful lines show different recording car runs, and there are many of these lines. They are on the same track, but on different points of time. And we are looking on exactly one point in track, and look how these data degrade. And we learned one very simple figure, a formula, which told us the initial quality, the quality at any time t depends on the initial quality and then deteriorates over an non-linear. And that's one formula which is valid for all track, for all the different parameter sets. But the rate of deterioration B, that's the key for the prediction. And this rate is very much influenced by the different parameters. You can imagine if you have very heavy traffic, you have more deterioration than having only a branch line with a few trains, for example. The main results in costs are, here it's pictured the average annual cost, so the annuity. And we learn that the biggest cost portion of railway track is the depreciation. Track is expensive. Therefore, we need high service life because the green bar is investment divided by service life. That's 60% roughly. In turnout, even a little bit more. And then we have two other portions, maintenance and these costs of operational disruptions. We call it cost of operational hindrances. They are at roughly 20%. That means we have a very stable structure. This structure is valid for track, for turnout, and for most of the parameter sets. But one thing is quite important. I mentioned we have to look on subsoil and dewatering. So we did this analysis for sections with poor dewatering. Poor dewatering increases the maintenance by far. And this gives an increase of total cost by 2/3. That's just a drainage problem or a dewatering problem. If you have a soft soil, good dewatering, but soft soil, so let's say nearly no good basement for track, then the costs are more than doubled. If you have both poor subgrade and poor dewatering, the costs can be 10 times higher, nearly 10 times higher. So that's in case of area where you have freezing in winter. If you don't have freezing, it's not so bad. Then it's only 5 to 6 times higher cost. So there is one important first result. You cannot do a sustainable track on poor soil or with poor dewatering. These are the preconditions. To have a good soil and a good dewatering are the preconditions for having a sustainable and economic track. Let's go on with these things. We have the basic of a proper high quality track, high loaded track. The following analyses are all made for relevant track. So let's say 70 to 100,000 tons per day in track. What can we do? What could be strategic ideas? We can save money. We can save money in buying poorer components, lighter components or poorer components. What would be the consequence? Poorer component quality increase maintenance and or decreases service life. And the savings you do when you invest, you have to pay back quite badly. So this is not economic. On the other hand, we could take good components, but we do little maintenance. Reduced maintenance decreases service life. If there is no maintenance done, nearly no, service life would be halved. And that would be even a worse picture than shown here. We could prolong the service life. That's a good idea. Service life is the biggest cost portion. So depreciation is the biggest cost portion, so we increase service life. However, when we do this using speed restrictions, the operational disruption costs increase. And this is highly uneconomic for all main lines. It might be a solution for a short time for branch lines, but never for main lines. So now we see what we should not do. We would like to know what we should do to even better the first situation, proper high quality track, which is a sustainable track. And we can do it in implementing innovations. Innovation normally target on increasing service life and less maintenance. Therefore, the disruption is also decreased. All the bars go down. I will show you an example for this. So that the summary of this picture is, it's all about quality. Poor component quality, high costs. Poor maintenance quality, high costs. Speed restrictions because of poor riding quality, high costs. Innovation, we will see. One of the innovation was, as an example, we use concrete sleepers with undersleeper bed. So we put an elastic bed under the sleeper. The idea was to do that because the contact area between this concrete sleeper and the ballast is very small. And if the contact area is small, 5% without stabilizing, 10% with stabilizing, then the stones, the few stones in contact are overloaded, break, and you have initial settlement. Giving an elastic bed allows the stones to press into this elastic bed, and the contact area is roughly 30%, it's tripled. The expectation is if we have more contact area, we have less ballast degradation, less maintenance demand, and that means longer service life because the ballast is the critical element in the ballasted track. If ballast is worn out, you have to go to renewal. This is an expectation only. So we did analysis And we saw 0.5 millimeter was the standard deviation of a new laid track. When we do it with undersleeper beds, the quality, the initial quality is better. Think on the formula. But even much more important is the degradation, the B rate. With normal concrete sleepers, it's 0.14 millimeter per year. With undersleeper beds, it's half the value. And that means, yes, this innovation pays back. We can reduce the average annual costs by 1/3. The cost figures for European costs are 5% more investment, 50% less maintenance demand, not 50% less maintenance, but 50% less maintenance demand, and an increase of service life of 25%. The high initial quality and the reduced maintenance give a lot of savings. And with this, I'm already coming to the summary. There's nothing more expensive than short-term saving. If you save money in building poorer components, if you save money not in doing maintenance, this you will have to pay back very badly. On the other hand, there's nothing more economic than high quality. This high quality must be ensured in both in construction and maintenance. The bitterness of poor quality remains long after the sweetness of a low price is forgotten. And this is the basics I wanted to describe today. That's the content of a 3.5-day seminar where we speak about asset management, about the different approaches, about forecasting, prediction, organizational matters, and so on. Thank you very much for listening to me.
Thank you so much. Thank you so much, Professor. So now, since time is very limited, we'll go for very relevant questions to Professor. So 3 questions we are summarizing in one for Bangladesh Railway. So first questions for ADG infrastructure for Mr. Rahman. Based on the methodologies and tools that you learned from the training in GRAS, what were the first concrete changes that you implemented in your railway asset management practices in Bangladesh? And also, you can educate us, what are the main barriers that you anticipate in applying those approaches that you learn in GRAS, specifically data availability, which is really a challenge, and also institutional coordination and the budget constraints. And then what is your plan? What is your suggestions to address those? And what is your next concrete step that you plan for improving railway asset management practices in Bangladesh? Since you are developing huge railway program, and current government also has a huge plan for improvement of Bangladesh Railways together with all development partners. So over to you, Mr. Rahman.
Actually, we are presently in a very bad condition of maintenance. We are taking many infrastructure projects. All are, new construction of railway. Some are gauge unification, some are new connectivity of the track, but maintenance structure is not up to the mark. So, actually, in Bangladesh Railway, we have 2 types of track. Some concrete sleeper track, some are steel sleeper track, conventional track. So normal track we are maintaining with the manual manpower, and the concrete sleeper track we are doing the machine maintenance, but it is in a unstructured way actually. So in GRAS, what we could understand that basically in European maintenance, in their maintenance they use track recording car and they use software. The data what they produce, automated producing data is installed in their system, and they do programming accordingly. But at this moment, Bangladesh Railway, we cannot implement this kind of high precision standard maintenance at once. We have to go to this position in a gradual way. So what in the presentation, what I introduced, we have taken some, pilot project. We actually, at this moment, no, top management doesn't know the condition of the track. Some localized management, they collect their data manually, and they take program manually. They provide their budget proposal. Accordingly, it is approved, and definitely what it is required, it is not complied 100%. Some lacking are there. That's why the track is deteriorating from their very much expected life. So at this moment, we are just collection of this data would be manually, but it would be included in the system. And from the system, we can mathematically calculate and understand what we have to do, and we can show our government that this is the track standard, and this is the requirement. At this moment, we cannot provide our proposal statistically, but in this way, we can collect the data statistically, and statistically we can show our government, so that if government cannot support accordingly, the government, at least they can understand that due to this kind of every year's lacking, the condition of the track becoming deteriorated, and rehabilitation work is necessary, something like that. So at this moment, we have done some pilot work, and we want to introduce this pilot work for total Bangladesh Railway. And gradually, when we will increase our speed, precision type, maintenance is required, and we will go for in the high standard maintenance afterwards. Thank you.
So if we note that you are in a transition from reactive to proactive and then predictive. So now you are actually entering to the automation, but of course it will take time. So we would like to go to Mr. Oleg, who has a huge experience, and how these planning stage initiatives on maintenance and modernization and capacity building align with our ADB broader perspective, and how basically in future we can help to translate these into a sustained investment and technical assistance. So over to you, Mr. Oleg.
Thank you very much for this question. I would say that I'm not a railway specialist as such. I have more background in logistics and supply chain management, and I worked with different railways during my career on the side of the clients, with Russian railways, Kazakh railways, and later in my career with Uzbek railways, Kazakh railways, Tajik, and Kyrgyz. So I would say that each of the railways, which here in our region, in Asia and Pacific, they have somewhat different challenges depending on their life cycle development. So some railways are pretty old. They have quite a lot of assets. They have old culture, which is driven by production and operations. In many cases, the networks are complete, and one of the major questions is actually to maintain assets properly. And here often one of the main objectives is not actually about the specific tools and technologies, but more about the setting up the proper objectives. And of course, many companies, railway companies and railway administrations in our region, they have to deal with the first order of business is actually how to generate revenue from the operations, how to become more customer friendlier. The next question is about managing costs of operations, and management of assets is quite important part of this, because you can sweat your asset, but after that you will have to invest much more in the asset. And that kind of behavior is actually typical not only for the public administered organizations like many of the railways, but also in the private sector. You can see that behavior. So the most important question is how to fight with this desire to get quick gains, get some financial results, forgetting about proper maintenance, and make sure that the assets will serve for a long time. So basically we're talking about preventive maintenance, we're talking about performance-based maintenance, because in some of the countries where we operate, like Central Asian republics, they still do not use that approach. They say, okay, we have national standards still since the Soviet times, so you need to replace this specific rail after 10 years, and et cetera, et cetera. So it's not based on knowledge. I would say that quite a lot of actually, and we support quite a lot of reforms in the railway sector. I would give an example of the railway with which I work currently. This is the Uzbek Railways. Just yesterday, or a few days before, it was announced that the so-called Uzbekistan National Investment Fund issued its first IPO in Uzbekistan. So the public organization, National Fund, National Wealth Fund, issued the IPO. This is the organization which actually owns Uzbekistan Railway Infrastructure Company. So the idea is that the infrastructure is owned by someone, and all potential players receive equal access to the track. Of course, based on the competition and based on knowledge. Like you can have your own private fleet, you can have your own traction capacity, locomotives, you have access to the network. But basically, currently, when the organization is actually publicly owned to some extent, it's not only by the government of Uzbekistan, there'll be someone who will be interested in the future value of those investments in railway assets. So hopefully it will create some kind of the future push for using those ideas and technologies which I discussed here.
Thank you. So, Professor, I have only 2 minutes for you just to suggest, actually building on your experience with Bangladesh Railway and based on your expertise actually worldwide, what is your suggestion? What could be the next step forward actually, how we can partner with Bangladesh Railway in future in regards to the maintenance strategy and then railway asset management and going forward? Over to you, Professor.
Yeah, thank you. First of all, we have to understand that the change from some maintenance to predictive maintenance cannot be done in one step. This is a long way to go. It starts with the requirement of data. It starts with the requirement to change national standards. Sometimes they are most of them are knowledge driven, but the knowledge is very old, and the knowledge of this track where the knowledge is based on is not existing anymore. So we have to change standards when we see that it is necessary, and we have to start getting data. That means we need to start collecting data, first perhaps on a simple way, but soon it should be recording card data. And then it takes nevertheless time, because we need time sequences, and time sequences means we have to measure a certain time until we can analyze the trends. But if we start to look more on quality behavior, first step perhaps on simple measurements, but done in a constant time series. This allows to get the first ideas, and later on it can be detailed when we have based it on recording cars. So I think the first step is to have a list of components, to see how these components behave. First of all, in simple measurements, later on in more sophisticated measurements, and especially in a lot of analysis. Data are essential, but data alone is nothing. We need to have a lot of analysis to understand why something deteriorates how.
Thank you so much. Thank you so much. So we can take one or two questions from the audience before we close. If anyone, yes, please.
Thank you. It's a very interesting and insightful presentation for all the panelists. My name is Daisy from MRT Jakarta, Indonesia. I'm very interested with the topic today about asset management. If I may, I want to ask two questions. First, in terms of asset life cycle, is there any asset useful life policy or regulation in the country, and who should set this useful life of asset? Because sometimes in the physical, when we set the asset useful life, it can be not 100% accurate. Because sometimes the asset is still can be used in the real physics. So who is should be set this useful life? The second is in terms of since I am from financing department, in terms of asset management, we all know that the asset replacement and maintenance will be need high financing and high funding. And how is this asset management can be connected with the funding needs? Because the funding needs is will be needs within all the life cycle of the asset. And we also want to make sure that the financing also sustainable with this financing need of asset displacement, and how should this asset management connected with that needs? Thank you.
Professor, over to you.
Yeah, useful service life, that's a really tricky question. When you look on service life, you want to have the minimal and the minimal costs of track. So the longer the track is in operation, the less is the depreciation. This is a trend which is going down, which is speaking for longer service life. On the other hand, the maintenance costs increase. That's the trend against. So this is a trend showing increasing costs. In principle, it's very simple. You add both of these costs, then you have the cost of total ownership, and this has a minimum as the one trend is going down and the other trend is going up. And this minimum is the useful service life. There is only one useful service life. If you reinstall the track too early, you waste assets. If you reinstall the track too late, you waste maintenance. But to do this exactly needs to see the trend of the maintenance, of the increasing maintenance, and that's again a data question. So the useful service life is just an economic question based on all the data which you have. In a first step, you can do it in a more simple way. In comparing different options, you say, okay, I will keep it for 25 years. The average annual costs will be that. If I keep it longer, I will have this and that more maintenance. My average annual costs are another figure, and you choose point by point which year should be the best one. But finally, it's the functions of depreciation, that's very simple, but the function of increasing maintenance that requires a lot of data. And the budget, and normally when we start with asset management, and that was nothing else different in Europe, when we start with that, we learn if we want to have a sustainable track, first of all, we have to invest. We have to invest in better quality with relaying. We have to invest in more maintenance. And the savings, we can prove the savings will come, but they will come later. And that's not so much liked, to spend money now and wait for the savings for a time. So in most of the countries I know, they started with implementing asset management and sustainability into track on a limited network, let's say only for one very relevant main line, and to do it there, to limit the additional investment costs, to limit the additional maintenance costs. And when this first line starts to show the savings because of better behavior, because of more service life, then you get the savings and you can spread these ideas more over the network. In Europe, I can say in Switzerland, they have a full, spread it over all the network and it's working. In Austria, it's the main network is sustainable, but they could not spread it to all the branch lines simply because of the budget problems you mentioned. You have to do it step by step. It is a long way to go, but I think it's the only way to ensure that rail traffic will decrease in costs over a longer time. Thank you for the question.
Thank you so much. So thank you so much. Thank you, ladies and gentlemen, for your kind attendance in this very important sessions, but we will continue in future in some other forum. So thank you so much to the speakers and discussant. So give a big hand for all of. So thank you so much. This is actually just to end of the sessions. Thank you again.
Thank you.
Actually 8 minutes.